CH2OH, and if you are going to check the hybridization, it's sp3. And since, let's say, can you tell me the degree of this carbon? Can you tell me the degree of this carbon that I underlined?
1.
After that, what
2.
is the degree of this carbon? After that, this one. What about this one? 3. So we can also say which type of alcohol is this. So we can easily say this is your primary alcohol, this is your secondary or 2-degree alcohol, or this is your tertiary, right? In the same way that we did for haloalkane, right?
Yes.
Now again we are going to do for, do you know what is allylic alcohols? Since it also comes under sp3 hybridized carbon OH bond, sp3 COH. So basically what is allylic we also have studied in the previous class. So it should be like this: CH2 double bond CH single bond CH2OH. See, what is the difference or what is the concept behind it? To the carbon which OH is connected must be sp3, and adjacent carbon to this sp3 carbon should be doubly bonded. This type of alcohol is known as allylic alcohols. Is that clear?
Yes, sir.
Also, can you tell me whether this one is allylic or not? So what you need to do, it's very simple. You just need to check the hybridization of the carbon which is connected with OH and check the adjacent carbon to this sp3 hybridized carbon. So as you can see, this is sp3 and adjacent carbon is this and this. And since this adjacent carbon is doubly bonded, that's why
sp2.
it is an allylic alcohol, sp2. That's good because carbon making double bond. Is that clear?
Yes.
Okay. Also, can you tell me what about this primary, secondary, tertiary alcohol? What type of alcohol is this?
Tertiary?
Did you say tertiary?
No, it's primary only.
It's secondary. Think about it. To the carbon which OH is connected, it is connected to 2 carbon only. That's why it is 2-degree. And since OH is connected to 2-degree or secondary carbon, it is secondary alcohol. Yes or no?
Yeah.
Got it?
Yes.
Also, we are going to do for this. This also comes under this sp3COH, and which is also known as benzylic alcohols. And in this, you can see the concept is similar. That means basically to the carbon which OH is connected must be sp3 hybridized. Can you tell me whether this is benzylic alcohol or not?
It is.
No, not. Did you check the hybridization of the carbon to which it is connected?
sp2.
sp2. So will it be benzylic alcohols? What does benzylic alcohol say? To the carbon it is connected should be sp3.
sp3.
And it is sp2, so it is not benzylic alcohols. It's not benzylic alcohol. Can you tell me whether this is benzylic alcohol or not?
Yeah, this is benzylic.
Yes. What you need to check, first check the hybridization of the carbon to which OH is connected, and then check the adjacent carbon to this carbon, which should be doubly bonded. So it is benzylic alcohol. Okay. Also, it's very important to note that allylic and benzylic Can be primary, secondary, and tertiary. Is that clear?
Yeah.
Very good. Now, in the same way, we can divide this phenol, that is your, what we say, phenol, and this is your monohydric. And if you have 2OH, this will be your dihydric, monohydric, dihydric. If you are going for 3OH, that will be your trihydric, right? This is trihydric. This is your dihydric. And this is your monohydric. Okay, it's very easy. Now, the second classification comes to the compound which contains sp2COH, which is known as, its name is vinylic alcohol. This vinylic halide we have studied in the previous chapter, which means CH2 double bond CH2 CHX. This is vinylic alcohol halide. Allylic halide, that means CH2 double bond CH double single bond CH2X. This is vinyl. Wait a minute. This is allylic or allylic halide in the previous chapter. If you are going to replace this X with OH, it will be allylic alcohol. This is vinylic halide. Vinylic halide. If you are going to replace this X with OH, it will be vinylic alcohol. And this means basically to the carbon which OH is connected is sp2 hybridization, then it is vinylic alcohol. In the way you can see, this is your vinylic alcohol. This is also your vinylic alcohol. Are you getting my point?
Yes.
Okay, can you change the slide?
Yes, sir.
So now we just talked about alcohols and phenols. Now go for ethers. Ethers are basically, we can divide it into two parts. One is basically your symmetrical ether, and another is asymmetrical ether. Asymmetrical ether. You know the general formula ROR, either you can write or ROR dash. This will be asymmetrical. That means basically on both sides the alkyl group are different. That means asymmetrical, and on both sides alkyl group are same. That means symmetrical. If you have this CH3O CH3 alongside O, you can see same alkyl group, so it is symmetrical, and alongside O different alkyl group, that means asymmetrical. Are you getting my point?
Yes.
So it's very easy. I want you, this is your homework part, okay? So in text question, I will write this with the flow. And text question number 11.1. It's your homework. Just note it in a page. So do you have any doubt till this?
No, sir.
Okay. Then moving to the next part, which is nomenclature. Nomenclature. Do you have any doubt on nomenclature? Actually, this nomenclature you have studied it in class 11th very well. If you still face problem in this nomenclature, please do let me know. Are you comfortable with nomenclature? Generally, student in class 12 has issues with nomenclature. What about you? You were not audible. Still not audible. Not at all. Can you respond me in chat box? Firaz,
Yes, sir.
so are you comfortable with this nomenclature?
Yeah.
Okay, very good. So I'm going to give you some questions. Please do it, and then we will move to the next part. Please do it. Yeah, let me know when you're done with this. Please do let me know when you are done with this. Firas, I'll be back in a minute from washroom. Firaz, are you done with this? Firaz, let me know when you're done with this. Firaz, am I audible?
Yes, sir. The first one is
Yeah, just
3-methyl
yeah,
butan 2-ol.
butane 2-ol. Very good. What about the second one?
That one I didn't get.
Okay, this is the first carbon, second carbon, third carbon. So it is prop and all are singly bonds. So propane 1, 2, 3. Triol. Yes or no?
Yes.
Very good.
Next one is phenol.
No, not phenol. It's cyclohexanol, na? Is it benzene?
No, yeah, cyclohexane.
Cyclohexane. What about the after this?
Cyclopentan 2-ol.
Cyclopentane 2-ol. 2-ol or 1-ol? It will be. We are going to give the numbering from where functional group is present, right?
Yeah, 1-ol. Yeah.
Do the next one.
Phenol.
Phenol. Very good. Or we can also say benzenol. Phenol was basically it was initially common name, but now it is treated as phenol. IUPAC name.
2-methyl benzenol. No. 2-methyl phenol.
Yeah, 2-methyl phenol you can say, or 2-methyl benzenol you can say. Okay.
Yeah.
So it's now famous for phenol. So 2-methyl phenol. What about this one? It will be 1, 2, 3.
Diol.
Benzene, yeah, benzene 1, 3.
Diol.
Diol. So it's very easy, right?
Yeah.
So you need to do the practice for nomenclature. Whatever is the question that is present in your NCRT, either in in-text or exercise, you are going to do it all, because these are all 3 marks. If you are going to give some times to these nomenclatures, you will get 100%. Okay. Now, So do you know how to do the nomenclature of this ether? Yes or no? How to
Yes.
do the nomenclature of ether? Okay. So I'm going to start from very basic. I'm going to give you a chance to prove yourself. Please do it. I will give you more question on this because it is very less. Firaz, do let me know when you are done with this.
Sir, first one is
Yes,
methoxymethane.
very good. Methoxymethane. Then
Then 1-methoxypropane.
we can directly write methoxypropane, right?
Yeah.
Then or 1-methoxypropane.
2-methoxypropane.
Yeah, 1, 2, 3. So on the 2 it is methoxy. So 2-methoxypropane. Very good. What about this?
3-methyl.
Yeah,
3-methyl propoxy
not propoxy. This is the. Can you
butoxy.
tell me which? No. Can you tell me? Did you say butoxy?
Yeah.
Yeah, it's correct. Can you tell me which one is parent chain, left or right?
Left. The benzene group.
Because it has more number of carbon. So 3-methyl.
Butoxybenzene.
Oh, wait a minute, please. Butoxybenzene. It's correct. Very good. Please be clear with your nomenclature. I want to give you some more. And then it comes. This is your CH3. This is your CH3. This is your O2CH4. Please do name it. Please do let me know. Firaz, are you done with this? See, this will be
Yeah, that
basically this will
is
be
2
your
methoxy,
no, it will be
ethoxy,
uh, 2
2 ethoxy,
methoxy or one 2 ethoxy or methoxy.
ethoxy.
Uh, So we are going to give preference to this because it has 2 substituent. So it will be 2 ethoxy, and after that 1 comma 1
1
dimethyl,
dimethyl
1 comma
cyclohex.
1 unit cyclohex. Very good. Now if you are going to do this 1 2, so 1 comma 2 dimethoxy ethane,
Ethane.
right?
Yeah.
So this is basically your nomenclature part. Now if you are going to, the next topic is basically your structures of functional group. Structures of functional group. Now see what it is. Structures of functional group. So we are going to take alcohol first, and in alcohol I'm going to take this methanol. And since we are going to take this methanol, you can see this is your functional group OH, and this is your methanol, and then we are going to take this phenol. As you can see, this is your phenol. And then we are going to take this ether, that is methoxymethane. Now see, you know that this oxygen will have 2 lone pair because it's making 2 bonds. So this angle will be 108.9 degree due to the repulsion. And it's also, there is 2 lone pair here and here. It will be less repulsion, more stable due to resonance. It is 109 degree. And this angle is basically 101.7 degree, the most due to more repulsion and bulky group. So sometimes it has been asked to compare the bond angle between this ether, which is your methoxymethane, and this is your phenol. So always keep it in mind. The lesser bond angle in methanol, then phenol, and then methoxymethane. Is that clear? Can I change the slide?
Yes, sir. Yes, sir.
Thank you. Thank you. Now see, this is very easy. Now we are going for the preparation of alcohol. Preparation of alcohols. So as you can see, this is your preparation of alcohols, and the first is preparation of alcohols from alkenes. And there is a mechanism how we are going to prepare alcohol from alkenes, and that is the first part from alkenes is by acid catalyzed hydration. Acid catalyzed hydration. By the name you can see we are going to do hydration in the presence of acid in alkenes, and we will get alcohol. So as you can see, you have an alkene like this. So what you need to do is just hydrolyze it. Hydration will take place, addition of water in the presence of acid. in the presence of acid H plus. So what will happen here? In and again. So what will happen? One of the bond will be broken. This bond will be broken, and H2O has two parts, H plus and OH minus. It will go along double bond. So bond is broken, and you can see H will go here and OH will be here. Is that clear? And generally it follows Markovnikov rule. So are you aware of Markovnikov from class 11th?
Yes, sir.
Markovnikov says that negative part or negative part of the addendum go across double bond, which has lesser number of hydrogen, and positive will go to that carbon which has a greater number of hydrogen. So if I'm going to give you this CH3 CH double bond CH2, and you are going to do hydration in the presence of acid, can you tell me the name of the product?
CH3CH, and then at CH there'll be a OH group, then CH3.
Can you tell me the name? Just write the product and let me know the name of the product.
Propanol.
Is it propanol or propane 2-ol? As you can see, this will have two parts, H plus, OH minus. This will be broken, and negative part of the addendum will go across double bond, which has lesser number of hydrogen. So it will be CH3CH, and there will be OH, and then CH2 was there. It will become CH3. So propane 2-ol, right? The name is propane 2-ol. In order to make your nomenclature strong, you should name the you should write the IUPAC of each and every product that you make or prepare. Now we are going for mechanism, and mechanism is very important here. And in this chapter, 3 mechanism is there, and you need to take it seriously because it will be asked in 3 or 4 or 5 marks. Okay, if there will be question on the same mechanism, it will be of 4 or 5 marks. So see, mechanism has 3 steps, and in the step 1, protonation of alkene will take place. Protonation of alkene to form carbocation. Protonation of alkene to form carbocation by electrophilic attack of H3O positive. H3O positive. Now what happens when you are going to mix H plus in this H2O? What will happen? There will be formation of H3O positive, hydronium ion. And this hydronium ion will be going to attack on this alkene. How it is going to attack on alkene? As you know that, wait a minute. As you know that this is a double bond, so it will directly attack. Oh, wait a minute. I should explain it in this. Wait a minute. Can I write OH3 positive, H3O positive in this way? Can I write this? And this will have positive sign. Always remember that on more electronegative element like fluorine, oxygen, especially oxygen, it is very most used in our reaction. On more electronegative element, positive charge is very unstable. If on more electronegative element, negative charge is there, that is well and good, it is stable. But positive charge on more electronegative element is very less stable. So what will happen here? It will try to stabilize itself. Oxygen will take electron from hydrogen, and now hydrogen will have deficiency of electron. So this double bond will break, and basically it will attack on hydrogen. So what will form? As you can see, oxygen took electron from hydrogen, So it will have negative charge and already there is positive charge. So it will form H2O and it will be eliminated in the solution. Now this attack on this carbon. So as you can see, double bond was there. Now it will be single bond and it will be like this and this. And on one of the carbon, hydrogen will go and another carbon, there will be formation of carbocation. As you know, I'm going to again explain this point. It's very important. And that is basically, this is one bond, that means two carbon, two electron. So one of carbon will take electron from one of the carbon and it will be negatively charged. And this will be positively charged, that what we call carbocation. And since now it has two electrons, this carbon has two electrons, it will donate one of its electron to hydrogen and then make a bond. Is that clear? Because
Yes.
so in the first step, you are going to make a carbocation by electrophilic attack of H3O positive. In a step 2, nucleophilic attack of water will take place. Nucleophilic attack of water or on carbocation. Carbocation, that means positive charge on carbon. That means basically this carbon will have deficiency of electron. As you can see like this, it has hydrogen and this will be in this. So H2O is there and H2O is rich in electron because it has two lone pair. And what it will do, it will basically attack on this. And as you can see, this will be basically reversible reaction. As you can see, this part will be as it is, this part will be as it is, but now this part is basically connected with oxygen, which has two hydrogen. And since, wait a minute, now as you can see, since oxygen has donated one of its electron to carbon, so oxygen will have positive charge. Is that clear?
Yes, sir.
Now in the third step, deprotonation of alcohol will take place. Deprotonation. To form an alcohol. As you can see, this is your C as it is. There was hydrogen and there is like this and this part is like. I told you, positive charge on oxygen is stable or unstable. Positive charge on
Unstable.
oxygen is unstable. So what it will do, it will stabilize itself. It will take electron from hydrogen. It will take electron
Plus
from
H2O.
hydrogen. Okay, and yeah, there will be H2O. The reaction is carried out in what? The reaction is carried out in water, hydrogen. So as you can see, this will take. So it will be like this. Now it becomes alcohol. Yes or no?
Yeah.
And the H plus that is released will be attacked by H2 and again form the hydronium ion. Okay.
Yeah.
So is there any doubt in this?
No, sir.
That you are facing? Very good. So please take it seriously and write in a short notes. It's very important. Now see, the second preparation of aldehyde from alkene is by hydroboration. By hydroboration oxidation. It's very easy. Generally, it gives you a primary alcohol. Primary alcohol. If you have this CH double bond, CH2 double bond CH2, and you are going to react this first, the first part is BH2 whole twice. That is basically diboron BH3 whole twice. that is B2H6 diol. And in the second step, if you are going to in the second step, you are going to do hydrolysis in the presence of H2O2, hydrogen peroxide, and base. Then what it will give, it's very easy. One of the bond will be broken and it will give CH3 and then CH2OH. It follows generally your anti-Marconi curve. I will explain the mechanism also. Anti-Marconi curve. If you have propene like CH3, CH double bond CH2, what you need to make is primary alcohol. So this H2 part, H plus and OH minus. And what does anti-Marconi curve will say? What does anti-Marconi curve says? Negative part will go to that carbon which has greater number of hydrogen. So it will go to this, OH will come to here and it will here. Are you getting my point?
Yeah.
So it's very easy. I'm going to show you the whole reaction. Now see, the reaction is very easy. I'm going to take this propene. CH3, CH double bond, CH2. Now, if you are going to do the reaction HBH2 whole twice, this has two parts. If you are going to break this bond, this will have negative and this will have positive, and you are going to break this. And according to anti-Marconi curve, hydrogen will come here, it will become CH2. Yes or no? Please do respond.
Yeah.
And this will be basically CH2BH2. Can I write this? Again, you are going to react this product with CH3, CH double bond, CH2. Are you getting my point? You have to do it 3 times. I'm going to write this BH2 as BH and H. Again, this part will be broken and one of the bond will be broken. This part is positive, so it will come here, and this part is negative, so it will attach with this. So I'm going to write this part first. Concentrate here. CH3, CH2, and then CH2, and then BH, and BH will be connected with this CH2, and this CH2 is connected with this CH, and you can see this CH is attacked by this hydrogen, so it becomes CH2, and after this CH there is CH3. Is that clear?
Yeah.
And we used the second alkene, and then again the third, CH3, CH double bond, CH2. And I'm going to write this BH as this. Again, this part will be broken and this part will be broken. And what you will get, I'm going to write this part first.
You will
so
get
it will be
thrice.
Yeah, very good. CH3, CH2, CH2, and B. After B, there was the on the right hand side CH2, CH2, and then CH3. And as you can see, this this bromine
And on B also.
boron will go this to this, so it will be CH2 and this CH, and this hydrogen will come here on this, so it becomes CH2 and then CH3. So can I write this as CH3, CH2, CH2 whole thrice B?
Yes.
Can I write this? After this, you are going to do the rest reaction, second part, that is in the presence of H2O, in the presence of 3H2O2, and then OH base in the presence of base. You will get 3 moles of alcohol, primary alcohol. In this way, we do the reaction of what does its name? Hydroboration oxidation. Okay. Is that clear?
Yes. Actually, boron is also a product, right?
Yeah, that is the byproduct. BOH whole thrice, but it doesn't don't consider the byproduct. Okay. B. You can write if you want to write BOH whole thrice. Okay. Can I change the slide?
Yes, sir.
Okay. Now we are going to prepare from the next method, that is from carbonyl compounds. Carbonyl. So the first is from carbonyl compounds. So first is by reduction of aldehydes and ketones. I will give you a very good point that from aldehyde you will always get primary alcohol, and from ketone you will always get secondary. Why it is so? So it's very simple, you can easily understand. This is your RCHO, and what I just said, you are going to react this with H2. Why H2? Basically, whenever we are going to do the reduction of aldehyde, you will get alcohol, and ketone you will get alcohol. If you are going to do reduction with a very high or most strong reducing agent, this carboxylic acid also can be converted into alcohol. So this reaction occurs in the presence of palladium, and you will get directly RCH2OH. How does this reaction took place? It's very easy. Can I write RCHO like this? Yes or no? Can I write this? Firaz.
Yeah.
Yeah. So reduction will take place. So you are going to break one of the double bond between carbon and oxygen, add hydrogen here. So what you will get, what you are getting, RC. There was already one hydrogen, and now you are adding
Plus
one
H2.
hydrogen carbon, and then so this is how you can make alcohol. Are you getting my point?
Yeah.
If you have ketone, that will also be converted. If you have RCOR dash and you are going to use this NaBH4, which is a reducing agent, and this its name, can you name it? NaBH4. Its name is
Sodium.
boron hydride.
Sodium hydride.
Boron hydride. So see, as you can see, it will be directly converted into RCH. OH, R dash. How the reaction took place? So it's very easy. Again, I'm going to do the same, whatever I did in the previous. Break the one of the bond between carbon and oxygen, add hydrogen here and here. As you can see, R dash is there. Now it becomes. So you can see from ketone you are getting 2 degree, and from aldehyde you are getting 1 degree. Are you getting my point? Yes or no, Firaz?
Yes.
1 GB. Wow. Can I change the slide?
Yes, sir.
Wait a minute, please. So this is the reduction of aldehyde and ketone to get alcohols. Now I'm going to do for carboxylic acid. This is the second part of carbonyl compound by carboxylic acids and esters. It's very easy. So I already told you, if you are using a strong reducing agent, like ALiLH4, and then you will do hydrolysis. What you will get, it's very simple. RCH2OH. Reduction will take place. Whatever is the number of carbon here, can you name it? Can you name it? What is the name of this compound? What is the name of this compound?
Ethoxic acid.
Ethoxic acid. How many carbon present on this in this carboxylic acid? 3 carbons, so it will be
3.
1, 2, 3. That means prop, and all are singly bonded, so propane, and then OIC, and then acid. So just remember, this is from propanoic acid. And also, can you tell me the name of an alcohol which have 3 carbon? Which have 3 carbon? Can you tell me the name of an alcohol which has 3 carbon?
Tertiary alcohol.
Name of an alcohol having 3 carbon. Propanol. It's very easy, no? So this will be directly converted into propanol. Is that clear?
Yeah.
Can I change the slide?
Yeah.
So this is how we prepare alcohol from carboxylic acid. But this lithium aluminum hydride is very, very expensive. So we have another method via this, via this ester, through ester. If you are already having a carboxylic acid, you are going to react this with alcohol in the presence of acid. So you will get an ester, and after ester, you can see you are going to react this with H2 in the presence of catalyst, then you will get RCH2OH, and again R-OH. How does this reaction take place? It's very easy to understand. So I'm going to explain. As you can see, this is your RC double bond OH, right? And this part, as you can see, you are going to react this with R-OH. So can I write this as negative, this as positive, and this as positive, and this as negative? So this will go to the negative, and you will get an ester RC double bond O, O R dash. Can I write this? Are you getting my point, Firaz?
Yes.
You got the ester. Now after ester, you are going to do the reaction with hydrogen, and a reduction will take place. So how the reduction will take place? It's very easy to understand. That is, you are going to break this bond, add hydrogen here, add hydrogen. Again, you are going to break this bond, add hydrogen here, add hydrogen here. So as you can see, this and this bond broke. So it will be RC. And with C, there were O. And now this hydrogen is connected with this. And with this C, 2 hydrogen is there, this and this. So it will become RCH2. And on the right hand side, you can see R-OH. Whatever is the alcohol that you have used in the first step will be, you will be getting in the last step. To reuse again, you can reuse it again.
Yes.
Are you getting my point? So this is how we prepare alcohol from carboxylic acid. as well as this, what we say, ester. Lithium aluminum hydride is expensive, so we use ester, and then we use alcohol with carboxylic acid to get this ester, and this ester after reduction you will get the 2 alcohol, the one which you used in the first step, and the required alcohol. Can I change the slide?
Yes.
Now the most important reaction or preparation is from Grignard reagent. From Grignard reagent. Why it is too important? So it's very easy reaction. So for carbonyl, I'm going to show you. This is a carbonyl that we are going to use generally this for vitamin base. We are going to use this for aldehyde and ketone. Can you see the screen?
Yes.
Wait a minute. Can you see the screen?
Yeah.
No, you can see this is your carbonyl compound, and that is that here refers to aldehyde and ketones. Aldehydes and ketones. So whenever you are going to do reaction of aldehyde and ketones with either aldehyde or ketones with Grignard, you will be getting alcohol. Now see how the reaction will take place. This is your RMG and X. So what happens here? So as you know, oxygen is more electronegative, so it will take electron from carbon, right? And as you also know that magnesium is metal electropositive, so it will have delta positive and this will have delta negative. Yes or no? And since carbon is giving electron to oxygen, it will have deficiency of electron, so it will attack here. Are you getting my point?
Yeah.
And this is now what it becomes. See, this bond will be as it is, and this R comes here to carbon, and this is O negative, and Mg is now positive, so it will come here Mg plus and then X, and this is basically your intermediate that is known as adduct. That is known as adduct. So in the first place, you are going to do this. After this, you are going to do the hydrolysis part, that is reacting with H2O. And H2O has two parts, as you know, that H plus and OH minus. What will happen here? This H plus is going to attack here, and this OH minus is going with Mg. So I'm going to write this part first. As you can see, this is like this, and O will get with H, and you will be getting a byproduct Mg with Mg. OH is going, so this will be the byproduct. Are you getting my point? And this is the main product. Is that clear?
Yeah.
Can I change the slide? Can I change the slide?
Yeah.
Now see, I'm going to give you some question. You are going to do it. You are going to react this HCHO with CH3MgBr, and you will get an adduct. After getting adduct, you are going to do the hydrolysis. You will get B. Please do it. Please do let me know when you are done with this. Are you done with this? Am I audible? Am I audible? Firaz, are you there?
Yes, sir.
Can you do this?
Double bond. Double bond.
See, HCHO is an aldehyde. So if you are going to do it for HCHO, it will be like this, and there is CH3
MGBR.
MGBR. Now you know that this will have delta negative, and it will go like this. So this will have deficiency of electron. So this will going to satisfy it. So what you will get, H will be like this, and I'm going to write CH, and then there will be CH3 that is attacking on that, and O negative Mg plus Br. This will be your adduct. After this,
Yeah.
you are going to react this with H2O. So what will happen? H2O has two parts, H plus and OH minus. So this will be going with this, and OH minus will be going with this. So now, can I write this CH and H as CH2?
Yeah.
And I'm going to write this CH3 on the left hand side. I can write this, and this will be your OH, and this will be your MgOH-Br. Got it? So I should write B plus C. This is your main product. This is your byproduct. Can I change the slide?
Yes.
No. I'm going to again give you a chance to react this with CH3CHO, and this is your CH3. I can change the CH3 to a methyl to ethyl, propyl, butyl. We can take anything. Are you getting my point? Please do let me know. The byproduct will be similar, same. Please do let. Are you done with this?
Yeah.
So this will be written as this. CH3 MgVr. You know that.
Then
this
CH3 attached to C.
so it will be CH3. Very good. C, and there is CH3, and this is O. HO minus Mg plus Br. After reacting it with H2, it has two parts, H plus and OH minus, which can easily attack here and here. So it will be CH3, CH3.
OH plus
Okay, got it.
MgOH.
Yeah, this will be, can I write this like this? Yes, I was writing like this. So both are same. You got propane 2-ol. This is also propane 2-ol, and this is also propane 2-ol. Yes or no?
Yeah.
Now I'm going to give you another. Please do write it. Can do this in the same way. If you are facing any type of problem, let me know. Are you done with this? Firaz? As you can see, I'm going to explain it. This will go like this. This is delta negative, delta positive. This will be attacking here. So you can see CH3, C O negative CH3 will come here, and there is CH3. And this Mg plus will go with this. Yes or no, Firaz? Firaz, are you there?
Yes.
H plus and H minus. So this will directly attack on this part, and you will get CH3, COH. There is CH3 and CH3. And Mg, OHBr. Got it? So do you have you seen that except methanol, all aldehydes react with Grignard reagent to give secondary alcohol. Secondary alcohol. If you are going to use ethanol, propanol, butanol, then secondary alcohol you will get. But with methanol, you will get primary alcohol. If you are looking at your notes, it will be primary alcohol. And with ketone reacts with Grignard reagent to give tertiary alcohol. Is that clear?
Yeah. Yes.
So this is basically your preparation of alcohol from Grignard reagent, in which we have learned that methanol will give primary alcohol. After that, every alcohol will give you secondary alcohol. Every aldehyde will give you, except methanol, you will be getting with every aldehyde secondary alcohol. But with ketone, you will be getting tertiary alcohol.
Yes.
Okay.
Yeah.
So basically, this is it for today. We'll see you in the next class. And also, example is there 11.2 in NCRT that you are going to do. Okay. Then we are going to study preparation of phenols, then physical properties, then chemical properties. We'll look into it in the next. Okay. Thank you.